Okay, so in today's class, we're going to look at functions that has already been transformed, and our job is to discuss or describe the sequence of transformation that happened to arrive at that function. So let's look at question one. The way we're going to do this is that we're always going to tackle this from what the parent function is so that we can do the sequence of transformation to arrive at what f of x is. So if you look at the highest level of abstraction for this function over here, you could see that the parent function is g of x is equal to the absolute value x. So something was done to this function here to arrive at what? To arrive at f of x. So the first sequence is, it looks like I added a 1 to the function. So I shift upward by 1 unit would mean that I'm going to take g of x and add a plus 1, which would mean that I have absolute value x plus 1, which is what f of x is. Okay, let's look at the next question. So for the next question, when I look at that function, I can see what the parent function is. I hope you also see it. That from that level of abstraction, the parent function, g of x, is x squared. So let's see. If I'm reading from left to right, then I can talk about this horizontal movement, and then I can describe the vertical movement. Okay, so my first step is shift to the right by 5 units, means that I took g of x and I took out the x out and I replaced it with what? X minus 5. Meaning that now I have x minus 5 squared. And then my next move was, now that I've done the horizontal movement, I can focus my attention on the vertical movement. It's -2. That means I'm going to shift down by what? 2 units. So again, I have gx minus 5 minus 2, which would mean I have x minus 5 squared minus 2, which is what f of x is. I could have equally done the vertical first, so it could have shifted down by 2 units. All right, so let's look at that. I could have either done 1, shift down by 2 units. That would give me g of x minus 2, which would have been x squared minus 2. And then I could what? Move it up, shift it to the right by what? 5 units. So shift to the right by 5 units. That would mean you got g x minus minus 2. That would be x minus 5 squared minus 2, which is what f of x is. So either way works. As long as you're reading from left to right and you're obeying the rules, you should pretty much not change how things are moving around. Okay? Let's look at the next one. So the next one, I see -2x minus 1 cubed. The parent function has to be x cubed. So let's do this. Let's read from just left to right. And let's see. So my first step is I can reflect about the x-axis, which would mean that I have g of x, and I have a negative in front, meaning I have negative x cubed. And then my next move, so I've done this, I'm going to go do this, which is a stretch. So vertically stretch by a factor of 2 would mean I have negative 2gx, which is the same as negative 2x cubed. And then I'm going to this one over here, which is x minus 1, which is telling me that I have a horizontal movement. So I'm going to shift to the right by 1 unit, means that I'm doing negative 2g, and then in place of x, I'm going to throw that out of the window, and I'm going to replace it with x minus 1, which now becomes negative 2x minus 1 cubed, which is exactly what f of x is. All right. Now let's look at the next one. So the next one, if you look at what this function is, you can see what the parent function is. The parent function is actually square root of x. All right, that's equal to g of x. So what I want us to do is let's just do all the vertical first. So I have to deal with this and then deal with this. And then when I'm done, I will do this body over here, the horizontal movement. Okay? So if I'm going to do this, again, I'm reading from left to right. So first I need to shrink by a factor of 1/2, meaning I'm going to take 1/2 g of x, and that's going to be 1/2 square root of x. 2, I could have also done the next one. So I've done this. I need to go tackle this one. What's the next one from left to right? So I need to shift up by 3 units, meaning I have 1/2 g of x plus 3. That is the same as 1/2 square root of x plus 3. And then now that I've done all the vertical movement, the only horizontal movement I have over here is x minus 4. And again, so reading from left to right, that is the first time we see that. So I need to shift to the right by 4 units, which would mean I have 1/2 g x minus 4 plus 3 is equal to 1/2 square root of what? X minus 4. So you end up with the same thing. That's what f of x is. All right. So I went vertical and then horizontal. You could have done it in the other way. You could have done all the horizontal component or all the horizontal movement first and then tackled all the vertical movement. Or you can just read from left to right, and as you encounter each component of that function, you are describing its sequence of events or sequence of transformations. All right. So if I went, so there are 3 things that you can see. I'm just not going to write the actual thing. If I went from left to right, then I would do this one first. So this is from left to right. Right? This is from vertical to horizontal. All right? If I did left to right, then I'll do shrink by a factor of 1/2. And then I would do the second, because I would have to move to the what? To the right 4 places. And then I would do that third. If I decided that I wanted to do horizontal to vertical, then I would have to do the horizontal movement first, and then do this one second, and then do this one here third. So there are 3 different kinds of solutions that you can get, but in all cases, I will end up with the same function given to me. You can try these 2 that I have and see if you don't end up with the same expression. Okay? All right, let's look at the last one. So the last one that I have over here is, let me just make this a little bit interesting. Let's do a cube root of 1/3 x. All right. So I have this function over here, and when I look at this, the parent function is the cube root of x. So step 1, if I'm reading from left to right, then I could do the 2 first, which is telling me that there was a stretch. So I can stretch by a factor of 2. So here, if I call this g of x, I have g of x times 2, which would mean that I have 2 cube root of what? Cube root of x. And then when I come in, I think I had a negative in here in my original question. Yes. When I get in here, I have a negative, and then I have 1/3. All right. So I've not talked about this, but -1 times 1/3 multiplication is commutative. So it wouldn't even matter if I did 1/3 first, and then I did the negative, which is the reflection. All right. I've been going sequentially in a linear fashion, which is perfectly fine too. But notice that this is -1 times 1/3. Multiplication is commutative, so you could do the reflection first and do the horizontal stretch, or you could do the horizontal stretch and do the what? You could do the reflection too. So that always works. But I think going on a linear path is helpful so that you don't get confused. So the way I'm going to do step 2 is I'm going to look at the negative and go, that's a reflection. So I'm going to reflect about the y-axis. So that means I'm looking at 2g, and then the x replaces to become negative what? Negative x would mean I have 2 cube root of negative x. And then lastly, I have 1/3, and if you think about it, it's a horizontal movement, and 1/3 is counterintuitive. It's actually 3. So I want to do stretch by a factor, or stretch vertically. Horizontally. By a factor of 3. Yeah. Would mean I'm doing 2g of -1/3 x. Would mean 2 cube root of -1/3 x. Okay. So again, I return myself back to what f of x is. So hopefully you find this useful. Sometimes you might ask yourself, why am I doing transformations, and what is its usefulness? And a major place where you can find transformations usefulness is animation. So in animation, you get movement of what? Of body pieces or body parts. So if you think about a car has tires rolling. And if you can get all the point on that tire and you want to move forward, everything needs to move accordingly. So that is transformation. You got to move to the left or move to the right, go up and down, bounce up and down, go backwards, go forward. Those are all transformations that the animator or the one that's doing the design would have to take into account and design it that way. So There are more interesting things than just looking at functions, but if you can look at animation, that's a huge deal over there where everything is moving. If you have all these characters that you've seen on TV that are animated, that's all they're trying to do. They're trying to move everybody in the right one, the right motion. All right. So I hope you find this interesting, and hopefully I was helpful.